Today we're going to talk about angles and radian measure. Yesterday we worked with acute angles, and this lesson we're going to talk about angles with measures that it could be any real number, so positive or negative. We have two parts of an angle. We have our initial side and what's called our terminal side. And we're going to zoom in, and your initial side in standard position is always on the positive x-axis, and then we rotate along this vertex. We rotate along this vertex, and that gets us the terminal side, or the ending point. And that's what this says right here. Now, we could also have negative angles. This angle is positive because it goes counterclockwise, that way. But a negative angle would go clockwise, and my terminal side could be anywhere, but it depends on the rotation, the direction of the rotation, if you have a positive or negative angle. I mean, I could still have that pink side be the terminal side, but rotate this way, and it would be a negative angle measure. So down here, we're going to draw these angle measures, and we're not going to be super exact. We're not going to get a protractor out. We're just going to estimate. 405 degrees, that may be hard to draw at first, but if we subtract a full circle, we get 45 degrees. And you can say, well, I know what a 45-degree angle is. It looks like this. But we need to notate somehow that we went around a full circle, because a 360 degrees is a full spin. So what we do, there we did that rotation, which was a full circle, which is 360, and then a little bit more. That would be your angle measure of 405 degrees. You need to note that we went around the full circle once and then went 45 degrees. For negative 65 degrees, well, we know that the quadrants, and we can go up here to look at that. Each quadrant essentially represents 90 degrees. So this is 90 degrees, this is another 90 or 180, this is another 90 or 270, and then that's a full 360. The same thing applies going in the negative direction. This is negative 90, negative 180, negative 270, and then negative 360. So going negative 65 degrees, we know will be a little bit less than going fully negative 90. So we're just going to estimate it's closer to negative 90 than it is to negative, or to 0 degrees. So maybe about here. That would be our angle measure of negative 65 degrees. Because negative angles are going clockwise. Positive 240. Well, again, we know that a straight line is 180 degrees. And then going down here, this rotation would be 270. So we want more than 180, but less than 270, but also closer to 270 than to 180. So this will be a good estimation for the angle. And then negative 150. Again, negative 150 is less than negative 180, but bigger than negative 90. So it's going to be about here. Will be your measure for negative 150 degrees. So again, when we're drawing angles, we want to draw our best estimate. We're not looking for exact, but close enough. Coterminal angles are angles in standard position with the terminal side that coincide. So basically, the starting and the end point are the same. It's just a different amount of rotation. If you are spinning 360 degrees, you spun a full circle. If you spun 720 degrees, you spun 2 full circles. You start at the same spot and you're ending at the same spot, but in 720 degrees, you rotated twice. Same thing, 180 degrees is half a circle. If you rotate 540 degrees, you've gone around a full circle once and then a half. So you are starting and ending in the same spot. So to get coterminal angles, we're going to add or subtract 360 degrees. So we're going to take 485 and minus 360. That gives me 125 degrees. So that is one coterminal angle, and that's our positive one. Well, if we take 125 and minus another circle, that's going to give us a negative value, negative 235. So that is a negative coterminal angle. They both have the same initial side and terminal side. And we're not going to draw these for the sake of time. Negative 75 degrees. Well, if we do negative 75 plus 360, we get 285. So that's our positive coterminal angle. And then our negative one, if we do negative 75 minus 360, we get negative 435 degrees. So that's our negative coterminal angle. And again, we could keep doing that forever. And sometimes it might be easier to find a coterminal angle if I'm asking you to draw something. Like we did up here. 405 was a difficult one to draw. See, we subtracted 360 degrees and said, oh, it behaves like 45. I know what that looks like, but we need to make sure we do that full rotation, that full circle. And then 120 minus 360 is negative 240 degrees. That's my negative coterminal angle. And then 120 plus 360 would be our positive coterminal angle. So coterminal angles, we're adding or subtracting 360 until we get something that we are looking for. All right, on the next page, we're going to talk about what's called a radian measure. A radian is just another way to measure an angle. And we can do radians in decimals, or we can do radians in what are called pi radians. Typically, we want to leave our angles in pi radians because that's more useful than decimal ones. But it's just another way to, like I said, to measure an angle. And it's what we're going to be using more frequently in this unit, are pi radians to measure angles. To convert between radians and degrees, we have these two formulas. It is important to note that 2 pi is 360 degrees. So when we're doing coterminal angles and we added circles, in radians, we would add or subtract 2 pi. And then pi, just a regular pi radian, is 180 degrees. So to convert between the two, we multiply the degree by pi over 180. That will give us pi radians. So let's do example 3a and b to show you that. So we're going to do 315 times pi over 180. Since we want to leave pi in our answer, what we're going to do is just do 315 over 180, and reduce that fraction, we get 7 over 4. So this is going to be equal to 7 pi over 4. Now, if the directions asked for a decimal radian, then you would multiply by pi. Letter B, convert negative 50 degrees, so negative 50 times pi over 180. So same idea. We're going to do alpha y equals, as a fraction, negative 50 over 180, and we get negative 5 over 18. So negative 5 pi over 18 would be our radian measure. And like I said, if you want a decimal, we can multiply that out and get that. Now going in the other direction, to go from radians to degrees, we're going to take that radian measure and multiply it by the reciprocal of this conversion, so 180 over pi. So example 4, pi over 6 times 180 over pi. The pi's cancel out because we have a pi on the top and bottom. And that means if you need to, we can do 180 over 6, and that reduces to 30 degrees. And then letter B, okay, again, the pi's will cancel, but the negative does not cancel. So it's going to be negative 180 over 12, and that reduces to 15 degrees. So going back and forth between radians and degrees, you can use those formulas. You will get good enough that you will memorize some of the important ones. And these are the important ones here. And again, it may seem like a lot, but there are patterns. And we're going to talk about some of those patterns. Look at the 45s. 45, 135, 125, 315. So all those end in 5. And notice that they all are a number of pi over 4. So that's a pattern that you can use. And we're going to talk extensively about that later on. So by memorizing the equivalent angle just in the first quadrant, so this is the first quadrant here. Here's our first quadrant. And for 90 degrees, you can find all the other special angles by using multiples of these angles. So like 30 degrees, 30 times 5 is 115. Pi over 6 times 5 is 5 pi over 6. So you can get your other angles from the previous ones. And you're going to find that out with this whole unit, is that if you know the first quadrant of things, you can then reflect it and use patterns to find the rest, so you don't have to memorize as much. So our last example, draw an angle with the given measure in standard position, then find one positive coterminal and one negative coterminal angle. So remember, in this instance, since we're in pi radians, a circle is equal to 2 pi. So we're going to keep subtracting or adding 2 pi until we get a positive coterminal angle and a negative one. When we are adding fractions, we have to have common denominators. So 9 pi over 2 minus, well, instead of writing 2 pi, I can write 4 pi over 2. Because this will reduce down to, this part right here will reduce down to 2 pi, which is a full circle. That is also something that is going to be used frequently. So now that the denominators are the same, we can say, oh, 5 pi over 2. So that's my positive coterminal angle. Now if I do 5 pi over 2 minus 4 pi over 2, that is going to equal 1 pi over 2, or just pi over 2. Well, pi over 2, if we look back up here, pi over 2 is 90 degrees, or you could use the conversion. So this angle right here is pi over 2, or 90 degrees. Now 7 pi over 5, we're going to subtract 10 pi over 5 because over 5, because again, that will reduce down to 2 pi. So this is equal to negative 3 pi over 5. Now we want a positive coterminal angle, so I'm going to take that 7 pi over 5 and add 10 pi over 5, and that's going to equal 17 pi over 5. So let's graph this now, and 7 pi over 5 to draw this 7 pi over 5, again, we're going to estimate where that is if we can, because 7 pi over 5 isn't one of our values here, but 7 pi over 6 is, and that's about 210 degrees, and we know 7 pi over 5 is bigger than pi, so it's got to be a little bit more than 180 degrees. Now over here, I realized I messed up. Yes, our coterminal angle is pi over 2 or 90 degrees, but we went around a circle. I subtracted 2 circles. So that means I should have had 1 circle, 2 circles, and that should have been added to my drawing to show that we went around the circle twice. And then the last one, negative 5 pi over 6. So negative angles, that means, we're going to go this way. Now, if we add 12 pi over 6, those are common denominators, I get 7 pi over 6. And then if I do negative 5 pi over 6 minus 12 pi over 6, that's negative 17 pi over 6. Now, I know where 7 pi over 6 is. If we look up here, it's right here, that 210 degrees. But since my angle is negative, I need to go in this direction and draw it. So radian measures can be confusing. So the more we work with them, the better that you will get. So thanks for watching the video. Make sure to like it and subscribe.